We'll now continue with section 4.3 and discuss specifically Descartes' rule of signs. Descartes' rule of signs tells us that if we have a polynomial and we see a variation in sign, which means that the function either changes from positive to negative or negative to positive, that we can draw the following conclusions. That the number of positive real zeros of the function is either the number of variations in sign, or is less than this number by a positive even integer, or the number of negative real zeros of the function is either the number of variations in the sign of f of negative x, or is less than this number by a positive even integer. So let's look at an example so that we can see what this is actually telling us. So we have a function f of x is equal to 2x to the third plus 3x squared minus 14x minus 21. So what we want to do is we want to identify the sign changes in the original function. So we start with a positive 2. We stay positive with the positive 3. Then we change to a negative 14. So right here, we have a sign change. It goes from being positive to being negative, and then it stays negative. So we actually only have one sign change in the original function. So I'm going to make a note of that. We have one sign change in f of x. Now, the Descartes rule of sign also says to look at f of negative x. So what we're going to do is we're going to take our function, I'm going to come down here, and I'm going to evaluate f of negative x, which means I'm going to put a negative x everywhere there's an x. And then we are going to simplify this function and look for sign changes. So we're going to have 2. Negative x to the third is going to be negative x cubed. So I'm going to put the negative in the front and the x cubed after the 2. We have 3, and then this negative x squared is going to become positive x squared. A negative 14 times a negative x will be a positive 14x, and then minus 21. So let's look for sign changes. We start negative, we change to positive. So there's one sign change. We stay positive on the 14, but then we change to negative on the 21. So there's the second sign change. So we have 2 sign changes for f of negative x. Okay, so let's look first at the negative x. So it says the number of negative real zeros of f is either the number of variations in sign, which for us would have been 2, or is less than this number by a positive even integer. So the smallest positive even integer is 2. So it's either equal to 2, okay, and I want to be sure that this is clear because the number of variations in the sign of f of x, or f of negative x, we had 2 sign changes in f of negative x. So it's either equal to 2 or it's less than 2 by a positive even integer. So less than 2 by a positive even integer, this is the smallest positive even integer that we could subtract off. So it's either 2 or it's 0, okay? So we have to take where we start and we have to reduce it by 2 to make it a reduction of a positive even integer. So I can conclude here that we have 2 or 0 negative real zeros. Now, I don't know which one, but it's one of those 2. All right, so that's one conclusion that can be drawn. All right, now let's look at this one sign change that we had in f of x. So the number of positive real zeros is either the number of variations in the sign of f of x, so this was 1 for us, or is less than this number by a positive even integer. So we would subtract 2 in order to have it reduced by an even integer. But 1 minus 2 doesn't make any sense because we can't have a negative 1 positive real zero. So the only definite answer that we have is 1. So we can conclude that there is 1 positive real zero. And that's our other conclusion. All right, so we know 1 positive real zero in either 2 or nothing for the negative real zeros. Okay, so let's go through this one more time with our second example, part B. Okay, so first thing that we're going to do is we're going to look for sign changes in the original function. So we start positive, we change to negative. That's one sign change right there. We're negative, we go to positive. There's another sign change. We are at positive, we go to negative. That's the third sign change. So we have 3 sign changes in the original function. Okay? So 3 sign changes in g of x. So what does that mean? That means that the number of positive real zeros is either 3 or, and reduce it by an even number, so reduce it by 2, it's 1. So either 3 or 1 positive real zeros. Okay, now we also have to look at the negative. So we're going to come in here and we are going to plug in g of negative x and look at what happens there. So we're going to put a negative x everywhere there's an x and look at our sign changes there. So we're going to have negative 3x to the third. This negative 3 squared is going to be a positive 9. So we have negative 90. Hold on, why do I have a 3 there? Let's just have an x. So we have negative, let me fix that real quick. All right, so we're going to have negative x squared would be a positive x squared. So we'll have negative 10x squared. We have minus 51 over 4x and minus 13 over 4. So how many sign changes do we have there? We have 0 sign changes. Okay, always is negative. So 0 sign changes in g of negative x, which means that we have 0 real negative zeros. So 0 negative real zeros. And that's the other part of our answer. So in this polynomial function, we expect to have 3 or 1 positive zeros and no negative real zeros.